Hello everyone. This is a short introduction to regression models in econometrics. In this lecture, we are going to look at the basics of how regression help explain relationships between variables. At the heart of regression is the population regression model. Let's start with the simplest form, which is simple linear regression model. It can be written as y equal to beta 0 plus beta 1 x plus epsilon. Here y is the dependent variable, x is the independent variable, beta 0 is the intercept, and beta 1 is the slope coefficient. The term epsilon, represented by the error term, captures all the other influences on y that are not explained by x. However, regression can also handle more than one explanatory variable. That's where multiple linear regression model comes in. Y is a function of beta 0 plus beta 1 x1 plus beta 2 x2 and so on until the last beta k xk plus epsilon. Here we have more than one independent variables. Let's look at the examples of simple linear regression model. Sales as a function of price, wages as a function of education, and weight as a function of height. Here, the second example, wages depend on education or years of education. But of course, we know that other factors like experience or IQ are captured in the error term. Hence, we can expand the model into more than one independent variable, just like the examples of multiple linear regression model. Sales as a function of not only price but also income, wages as a function of education, experience, and IQ, MPG, which is the fuel efficiency, miles per gallon, is a function of price and weight of the vehicle. You might ask, why do we need an error term? Why error term must exist in population regression model? Because no model can capture everything. The error terms account for omitted variable bias, measurement errors, model and functional misclassification, and other potential issues. In short, it represents the difference between our theoretical model and the reality. In practice, we don't know the true values of beta 0 and beta 1 or maybe beta 2 and 3 in the model. Instead, we use data to estimate them through ordinary least squares method. In other words, we gather the data for each and every variable in the model. For example, we collect data on wages, years of education, years of experience, and the IQ test score of the workers. And using the data, we can estimate them through ordinary least squares, and we can obtain the estimated regression model. The estimated regression model will give us y hat, or the predicted y, equal to beta 0 hat plus beta 1 x. Or simply we write b0 plus b1 x. Here b0 and b1 are estimates of the true beta parameters. The difference between the actual y and the predicted y or y hat is called residual. Residual show us how well our model predicts the data. If we can visualize the relationship, the red line here is the fitted line that estimate the relationship between this x variable and y variable. The dot is the actual value, and any point on the red line or the fitted line is the estimated or predicted value. So the distance between the dot and the fitted line is called residuals or the error. To summarize, regression models, whether simple or multiple, help us understand how variables are related. The error term ensures we recognize the limits of our model, and estimation through OLS allows us to apply this model to real world data. Thank you.